Welcome to this Functional Skills Level 1 Maths training video. This video contains information and guidance on Criterion 28. Group discrete data and represent group data graphically. At Level 1, and by the end of this session, you should be able to understand the difference between discrete data and continuous data, recognize examples of discrete data, such as shoe sizes or favorite colors, group discrete data into categories or intervals, create a frequency table to show the grouped data clearly, choose an appropriate graphical method to represent group data, and interpret the information shown in graphs to answer simple questions. Let's start with discrete and continuous data. Discrete data consists of distinct values. These are often counted in whole numbers. For example, the number of pets someone owns, a person's eye color, or their shoe size. In contrast, continuous data can take any value within a range. This data is often measured. For example, someone's height or a room's temperature. The key difference is that discrete data involves specific, fixed values, while continuous data involves measurements that can have decimals. A key point to remember is that you count discrete data but measure continuous data. When you're deciding whether data is discrete or not, ask yourself, can I count this in whole numbers? If the answer is yes, then the data is most likely discrete. Examples of discrete data include number of books, days in the week, and favorite colors. Discrete data is common in everyday life. Look for things that can be counted rather than measured. When you're presented with data, check if the values are whole numbers or categories that can be grouped. Now it's your turn. Which of the following are examples of discrete data? Pause the video, then press play when you're ready to continue. The examples of discrete data are the number of cars parked in a car park and the population of a country. A person's height and the time it takes to complete a task are continuous data. They can be measured and may have values which are decimal numbers. Grouping discrete data into intervals helps make large sets of data easier to understand. For example, a list of shoe sizes could be grouped in the following way: sizes 1 to 3, 4 to 6, and 7 to 9. If data involves categories such as favorite colors, then grouping is based on each category, for example, red, blue, green, and so on. Here are some steps we can take to group data. Step 1. Look at the range of values or categories in the data. Step 2. Decide whether to group them using intervals or categories. Step 3. Ensure interval groups don't overlap. For example, 1 to 2 and 3 to 4, not 1 to 2, 2 to 3 and 3 to 4. Now it's your turn. Should each of the following be grouped using intervals or categories? Pause the video while you decide, then press play when you're ready to continue. Let's check your answers. People's ages and clothing sizes should both be grouped using intervals, whereas genres of music and eye color should be grouped using categories. Pause the video while you check the answers and look at the examples of how to group the data, then press play when you're ready to continue. A frequency table shows how often each group or category appears in the data. Frequency tables have two columns. Groups. This is the data being grouped into intervals or categories. In this example, we can see different shoe sizes. These have been grouped into the following intervals: sizes 1 to 3, 4 to 6, 7 to 9, and 10 to 12. These intervals do not overlap. Frequency shows us how many times each interval or category has been chosen. For example, we can see that 7 people have a shoe size between 4 and 6. Here are some steps we can follow to create a frequency table. List the groups in the first column. Count how many times each group appears in the data. Write the frequency for each group in the second column. Now it's your turn. Pause the video and create a frequency table for the data shown below. Press play when you're ready to continue. Let's check the answer. Your table should look similar to this. The frequency can also be recorded as a tally chart. Graphs help make data visual and easier to understand. It's important to choose a graph or chart that will correctly present your data. Here are some steps you can follow to help you draw an appropriate graph or chart. First, decide which type of graph works best for the data. Include a title and label the axes of the graph. And ensure you use the frequency table to plot the data accurately. Let's look at an example of a bar chart. Bar charts are best for showing data grouped into intervals, such as shoe sizes. Another way of representing data is a pictogram. Pictograms are best used for showing data in categories. For example, favorite colors. You can see that the pictogram has a clear title, as well as appropriate named headings. The data is shown clearly and a key has been included to ensure it can be read accurately. Here's a question for you to try. Pause the video and draw a suitable graph to display the information in the frequency table. Press play when you're ready to continue. You can either draw the graph or chart on paper, or you can visit highfieldcore.com/tutorials/maths and use the chart tutorial area on our Highfield Core platform. This is also good practice if you will be sitting your functional skills exam on screen, as this is the same tool you would use in a live exam. Let's check the answer. A bar chart is the most suitable option as the data is shown in intervals. This example includes a relevant title, as well as correct labels for each axis. The information has been plotted accurately. It is important that your graph includes the following information: a title, clear labels on both x and y axis, a consistent scale, and accurately plotted data. One of the most common mistakes on charts is not to include a title, so it is especially important to remember this. Let's answer a few questions based on the bar chart we just looked at. Pause the video and answer the following questions, then press play when you're ready to continue. Here are the answers. Pause the video while you check them, then press play to continue. Here's another exam question to try. Use the table to create a graph or chart to represent the group data. Again, you can use paper or the on-screen Highfield Core tutorial area to create this. Let's look at an example answer. A bar chart is the most appropriate way to show this discrete data. You can see this graph includes a title, labels for the axes, and a suitable scale. The data has all been plotted correctly. Here's the final exam question. Pause the video while you answer the question, then press play when you're ready to continue. Here's how your table should look. Pause the video while you check, then press play to continue. Let's recap what you've learned in this video. You should now be able to understand the difference between discrete data and continuous data, recognize examples of discrete data, group discrete data into categories or intervals, create a frequency table to show the grouped data clearly, choose an appropriate graphical method to represent group data, and interpret the information shown in graphs to answer simple questions. I hope that you have enjoyed this video. Thank you for watching. Goodbye.